All right, so the second type of logarithmic equation we're going to take a look at is when we don't have multiple logarithms, we have a single logarithm. So the easiest way that we're going to solve this is to get the logarithm by itself first. We're going to isolate the logarithm. Then we're going to convert to exponential form and solve using same base, if necessary. We might not have to do same base, but we're going to wait and see what happens. All right, so problem number 4 here, I see that there is a -6 impeding the logarithm from being by itself. So I need to make that -6 go away. So I'm going to start by dividing out -6 from both sides. And that's just going to cancel off on this side and give me log base 3 of x minus 15 is equal to, oh, I forgot the negative there. Don't forget the negative, Miss Mara. -24 divided by -6 is +4. All right, so now I have a logarithm equal to a number. I can convert this to exponential form. Remember, you do the base to the exponent equal to the argument. Okay, so base to the exponent equals the argument. All right, so from here, I've got to figure out, well, what is 3 to the 4th power? So 3 to the 4th power is 81. I'm going to add over the 15, and I'll have my value of x. So I'm going to end up with x equals, let's see, that is 96. Okay, I still need to check for extraneous solutions because this number is getting plugged into a logarithm. But when I go ahead and check here, when I plug in x equals 96, inside I get 96 minus 15. I'm plugging that in right here, by the way. That's where that's coming from. All right, I get a positive, which is what I'm looking for. So this is in fact my solution. It is not an extraneous solution. Okay, so that's number 4. One problem left and we're done, guys. Short and sweet and to the point on this one, hopefully. All right, so for problem number 5, we have 2 log base 4 of 7x minus 1 is equal to 5. All right, so the first thing I need to do is I need to get rid of that +1, or rather the -1 by adding it to both sides. So we're going to have 2 log base 4 of 7x is equal to 6. The next step is going to be divide out that 2 from both sides so the logarithm is totally by itself. So now I'm going to have log base 4 of 7x is equal to 3. And now we're going to convert to exponential form. So the base is 4. The exponent is 3. And the argument is 7x. And then over here, 4 to the 3rd power, 4 times 4 times 4 is 64, is equal to 7x. I'm going to divide out the 7 and get a funky fraction. So I'm just going to leave that as 64 over 7 because there's no common factor between 64 and 7. And then as far as checking it is concerned, when I plug in x equals 64 over 7, I'm just doing 7 times 64 over 7, but that's not a negative. That works out to a positive, so it checks out, okay? It's not super common to have extraneous solutions, especially when we have just a single logarithm. That comes up more often when we have 2 logarithms involved and we're using that property of equality we talked about in the last video. Alrighty guys, your homework is on solving logarithmic equations. It's a worksheet. If you have any questions, please let me know. Good luck.